Okay, g'day guys. I think I finally have a bit of good news. As you do when you're trying to fix something and you re-establish all your voltage rails and replace parts and then stuff that still doesn't work, you go back and check your voltage rails again, right? Check this out. These two Zenas, 10 volts, 10 volts, they power that op amp. These two, 10 volts, 10 volts, they power that op amp. This Zena here, 10 volts, this Zena here, call it 10 volts. Don't know exactly what that does. Incidentally, that with the slightly lower voltage is on the side that doesn't work. Have a look at this, but 7 volts, 7 volts. And the same on the other side, incidentally, which I find interesting because the other side seems to be working. This is where it gets really odd. So now I'll put it into dual tracking mode. .8 volts, 4.7, 7, 7. So the side that works, just for some reason that voltage seems too low, always. Actually, let's have a look at it whilst I change things. I just turned the current pot and it changed a bit. You saw that? What about this one? Wow, that's gone to 1.4 now. Turn the current down, it goes straight back. Interesting. So, you know what I think's happened? Because you know what those Zenas power? Op amps. And transistors. But given what I did with all my screw ups, I'm going to put a safe bet that the 4 or 6 op amps, yeah, 6 op amps on the bottom board, I'm going to put a safe bet that some or all of them are damaged. Or knowing my luck, I might still have some wiring done wrong. So, without any further ado, back to the bench. So, I'm going to pause the video in a sec because I've just been sitting here staring at this for half an hour and I finally realised that. So I'm going to do a little bit more staring. I think this board's actually good, so I'll leave that off to the side. Strangely enough, something else I noticed. Actually, I'll just show you guys. If I power this board up on its own, without the outputs connected to it, and without the bottom board connected to it, which is really interesting because it's not under any load then, right? That Zener's got 2.2 volts on it now. That one's got 10. 2.2. 10. Nothing at all. Nothing at all. So obviously part of the circuit there continues on the bottom board to form the rest of the current loop for those Zeners. But also the current sink, whatever you want to call it, what's being driven from them is also on that bottom board. So given that all the resistor values check out on here, you know what I might do? I'm going to just double check my Zeners. Just not all of them, just those couple. Let's just quickly do that. Just a quick sanity check. It's running 0.6 volts in both directions. Maybe my leads went round the wrong way. That one reads 10 and yeah, my leads around the wrong way. They were right the first time. So this Zener here Hmm. 0.8 volts. I'm going to do a bit of investigation off camera. Otherwise I'm just going to be here forever. Although I guess for people that want to learn how to fix stuff and how to work out their fuck ups, other people's fuck ups, how to diagnose stuff, I guess this could be helpful. So maybe I should just upload everything. Okay, they both tested 0.8, so I'm guessing there's a transistor or something that's clamping across that when it's turned off. That comes in at 10. Can't remember if I did this one. $5.1. Hold on a second. That is suspiciously too close. Six. I think that's just a capacitor across it or something. I don't believe there's anything wrong with the Zenas I've replaced. I don't believe there's anything wrong with any resistors on there. I am going to put better quality resistors on for some of the resistors, and a couple of the values I checked that have drifted just a little bit I will replace with brand new ones on each side, but no, that's not what's causing this problem. And I've set these potentiometers equal to each other. I set the side that's got the problems on it to the same values that the side that was working perfectly, almost perfectly, has, for a good starting point. Wow, this is an interesting one. So I've either fried op amps or I've got buggered transistors. I'll go off and do a whole load of testing on said transistors and op amps, and I'll come back and let you know what we're doing. Guess what, guys? I have good news. So, you know how I was just saying it's getting weird because some of the Zener voltages were low. I just thought I'd go and have a look at my op amp wiring again, and wouldn't you know it, 4 op amps were wired up wrong still. What I had done is where the OR gate is, one op amp goes to each side of the OR gate, and then there's a positive and a negative connection and an output connection. The positive connection and one of the OR gate connections was swapped around. So I've fixed that now, and look at this. You guys can see that? Cool. So this is on independent mode. Oops. Turn the current up a smidge. Let's start dialing the voltage up. And would you look at that? That's working. I know it was already working, but just wait for it. So that's that. Right. Turn the current down. And put this in here. Now there's a few little oscillation problems and accuracy problems we still got to sort out, but we'll get there in a sec. I'll show you what I mean. Turn the voltage back up. Start dialing the current up. That's an op amp oscillating. I'll show you how I know that. Because when I go down, turn the voltage down, if I turn the current up then, oh. Oh. Remember, this is a 1 amp supply. That just shot 5 amps out. And I know you couldn't hear what I can hear, but that was ringing everything that could ring in there. The transformer, everything. Alright, anyway. So there's a little bit of oscillation. Other than that, working perfect. Okay, the current's still a little bit low, but we'll work that out. That's probably just one of my references off. Second output, we'll bump the current up a little bit. Yeah, that was on 0 before. Wait, what? No. This was just working. I swear to God. Oh, fuck. We'll try that again, perhaps. Hey? 0 volts. Wind the current up a little bit. Still got this bit of offset there, right? but the voltage winds up still too high, but it does control. Here's where it gets cool, but look at that. So both the currents are just about on. One's a little bit over, one's a little bit under, but the current circuitry is working, right? On both of them. What's more, guess what else is working now? You guessed it, auto tracking. And I'll show you. I'm going to set my first output to 5 volts. I'm going to set the second output to 5 volts. Right, 5077. $5054. Pretty close, right? I'm going to turn the first one up now, right? Sorry, I think I got the current turned now. Oh, I didn't put auto tracking on. Sorry. Let me set that up again. I'll turn the first one up to 5 volts. Turn the second one up to 5 volts. Five point eight, right? I'll turn the first one up to 10 volts. I'll turn the first one up to 20 volts. I'll turn the first one up to 30 volts. 30. 30. So, I've got to knock out some oscillation on the op amps, and I need to sort out, what do you call it, the current limits. There's some calibration issues going on there. Other than that, it's working. That's all I can do tonight. I'm tired as... I gotta stop swearing. I'm tired as... So I'm gonna leave it there for tonight. I am very, very pleased. I mean, you understand, I totally screwed this up for 2 days. I wasted a lot of time. I want to just give you guys a quick look at the panel meters too, so you can have a little bit of a better look from my perspective. Right, we'll give them both a bit of current so that there's current to charge the output capacitors so the voltage can rise when we turn it up. As you can see, meters are bang on. Put into auto tracking. Set this to 5 volts. This is now a ratio adjust knob. That's how this auto tracking unit works. Look at that. Well, I had a bit too much gain on that one. See? It works perfectly. pretty cool. So all we got to do is fine tune the current limits, knock out some oscillation, and I still want to know what the hell the go is with this just going up and up and up and up and up and still going. That's weird. But hey, almost there. I'll see you in the next one. Hopefully we can finish this tomorrow. I know I said that 2 days ago, but yeah, as you can see, we're basically there. So hopefully I can get this finished tomorrow. Thanks for watching, guys. Later. Alright, now I've got even better news. So I did some tests. The Zenas that the voltage was funny on, low, that voltage comes back up to normal when you play around with the current knobs. Now you might all remember that with the voltage at a certain point, as you turn the current up, it would go into oscillation. Sorry, I shouldn't have said that just yet. The current would all of a sudden go up to about 4 or 5 amps. And outside of a certain window it would stop. Now I could hear that, and it wasn't just the transformer humming, I could hear oscillation. I already knew what that was. This is your OR gate. This op amp's doing current, this one's doing voltage, same here. This capacitor here is the compensation capacitor for the current op amp. So what we're going to do is we're going to replace, sorry, it would help if I had the parts here on the table, one sec. Right, sorry about that. So, I know what you're all thinking when I pointed out the capacitor. Oh, he's going to put a bigger cap in. Hold on, hold your horses. First thing we're going to do is we're going to knock out a crap ton of inductance on the current shunt. We're also going to knock out a crap ton of inductance off of the emitter resistors. Bear in mind, all these resistors are in series. The current flows through them. The current is sensed off of that resistor. So we're going to lower all that inductance, right? Then we'll see what the oscillation's like. It'll most likely still be there, but just a lot better. Then with the better oscillation, we will then make the capacitor value bigger. But we only want to make it as big as we have to make it. Because you see the capacitor value, your compensation capacitor, it's going to affect your slew rate and your bandwidth. You don't really want to do that. You want, it's a power supply. You want super responsive response. So that's why we're going to try and minimize inductance first. Other thing I noticed, we might not even need to put the compensation capacitors on there. You know what I somehow did? Oh no, there they are. Yeah. I thought I didn't put the 10 microfarad capacitors back on. Okay, so yeah, okay, there's nothing capacitor wise I can really do to them that's going to benefit them anyway. Yeah, so I say we minimize inductance. Oh, by the way I fixed it, I should show you guys this too. You know how there was dragged down Zena voltages just on 4 Zenas? I worked out what all the Zenas are for, by the way. The 2 pairs of 2 give differential rails to these 2 op amps, and the 3 single Zenas on each side power the 3 op amps on this board, and that is why the voltage looks have dragged down, because these 2 op amps running off the one rail and this op amp's running off another rail. So sorry, 2 of those Zenas must make a differential rail and the other one makes a single rail. Just, yeah, anyways. So once I realised that something was dragging the voltage down and I knew where it was coming from, I had a look at the bottom of this board and I realised something. That's the AND gate. I had the output, this output wire, hooked up to positive, and the positives from both these op amps hooked up to the right, left, whatever you want to call it, of the AND gate, the voltage side. All I had to do was swap, that from there and that from there. Same thing here. Everything else was already correct. And this capacitor, I had to move from these 2 pins to these 2 pins. So that was my mistake number 3. Tell you what, next time I have to modify a board like this, I think I'm going to take a little bit more time instead of rushing it, because I just cut traces and stuck stuff in there and I rushed it, and it just, I mean, it's me, I can fix it. It's not like it's destroyed it or anything, but it's cost me a lot of time, and yeah, it was a waste of time. So I think I might take a bit more time next time on one of these jobs. But I just wanted to fill you guys in on what's happening. I'm about to go to bed now, so I'll leave this here for the morning, and when I get up and have breakfast and that, I'll come in and we'll change the resistors on this board like I showed you. Then we'll put it back together and see how the oscillation is. Is it still there? Is it better? And then we'll address the op amps if we have to. Alright guys, I'll see you in the next one. Thanks for watching.